Everyone, I'm excited to present to you our final project for CSC 805 data visualization. The title of our project was FlareGraph, exploring fire department statistics in San Francisco. This project has been a collaborative effort between myself and my teammates Naisarg Halvadiya and Sharanya Yellampali. So together we delved into the world of data visualization, and then utilizing some powerful tools, we brought forward a comprehensive exploration of the department statistics of the fire data set in San Francisco. Now, what's the tech stack that powers this? We chose Dash framework with Python for our project. The reason was its versatility and its efficiency. Dash provided an interactive and user-friendly environment for building web applications, and so it was an ideal choice for us. Plus, it gave us the power of a dynamic front end for data visualization. Another plus point was that it has seamless integration with Python, which allows us to leverage a lot of capabilities of pandas and other Python libraries, which we can use for efficient data processing and backend operations. Our mission with FlareGraph was not only to present data, but to also make it accessible and engaging for our audience. That is why we decided that rather than making just Tableau presentations, we would create an interactive web app where the user would actually be able to dive deep down into the statistics for every single data point. Um, we incorporated various data visualization types such as bubble charts, line charts, bar charts to provide different perspectives of the fire department statistics. This allows users to explore the data in such a way that it resonates with their preference and it helps in extracting meaningful insights. So here you have the first page in front of you. Um, as soon as you hit the web app, you immediately realize what its purpose is. Further below on the same page, we also discussed what this project is for, what are the main missions with this project. To make it accessible, we have also added a dark mode to this site, which you can access here. So let's move on to the first page of data visualization. The first page is the primary causes for fire-related calls. So here we have created a column chart, and as you can see, it maps out what is the count of the final calls of distress for all these distress calls that were made to the San Francisco Fire Department. One of the highest ones being medical incidents with almost 18,000 distress calls. We also had calls for alarms and calls for structure fires. So this was a representation of two-dimensional data. But as you can see that even though it gives some idea as to how what is the magnitude of the number of distress calls that are made for fire medical incidents, a pie chart was actually one which was able to capture it much better because you could see relative percentage. So medical incidents was 49% of the total amount of distress calls that was sent to the fire department. We had 8.6% for traffic collisions and 12% for alarms. And then we had even had 1%, 1.3% for electrical hazard fires and 1.55% for gas leaks. Here is the map, which is built on top of the GeoJSON data that is provided by the Open SF Data government website. Here you can see we have mapped out these individual locations, and these data points represent what were the distress call types that were made from these locations. As you can see, medical incidents was um, highly focused on the downtown side area, especially around um, Salesforce towers and such. Now we move on to the second part of the data set. I'm sorry, the second page. So here we did a little bit of a visualization for trend analysis of the incidents that are happening in the neighborhoods. So here we plotted a line chart for all the different types of fire incidents. Then we also made an area chart which shows the number of fire incidents mapped according to the year. And because we have used Plotly and Dash to create these graphs, these are extremely interactive. So here you can see the number, eagle eye view of the number of fire incident calls that were made in 2005 to 2010, 2015, 2020. But if you select any particular region, you can dive deep down much further into it and even look um, up to as far as individual dates. So, what are the number of fire incidents on 26th July 2010 or 15th October 2010, 17th January 2011? And when you hover on any single bar, it also shows the number of fire incidents for that particular date. We then moved forward and created a 3D bubble chart as well for the count of these fire incidents. And because relatively this is a zoomed out view, you are not able to visualize the magnitude. But clearly here we can see that the administrative calls versus the explosion calls versus the structure fire calls, their counts and the size of these bubbles actually represent the magnitude of the number of calls that were made. Now we move on to the third page, which is feature analysis and correlation. So, in this realm of data visualization, we have actually gone beyond the surface and delved into some concepts like and pre-attentive processing. So, we try to understand how our brains perceive and process visual information at a subconscious level. And that was the guiding principle for our design choices. So we have explored different representations of data, as I showed earlier, one-dimensional representation, two-dimensional representation, and three-dimensional representation, which offers a comprehensive view of all the information that we have at end. So in the feature analysis and correlation, we started with plotting a correlation matrix, which shows how the different attributes in this data set were related to each other. So as you can see, the some of the important discoveries that we made from this graph was that the more the number of flows that we had, the higher the damage was. Similarly, the higher the number of sprinkler heads that were operating, the higher was the estimated property loss. So all of these insights were very helpful to us, and I'm pretty sure that it will be very helpful to the end users of these websites as well. We then created a violin plot which shows the which shows the status of these fire incidents by their closing date. So as of 2024, how many of these are open? How many of these incidents are closed? How many have been rescinded? How many have been referred for hearing and such? We created a time series plot as well, which shows the difference between the alarm date time and the arrival date time. So the alarm date time is when the fire alarm was set off, and the arrival date time is when the first fire brigade arrived on the scene. Because this is a very zoomed out view currently, you might feel that these lines are overlapping, but if you zoom in forward, you'll realize that there is a difference. It's much more visible enough in the next page that I'll show, where we have created more graphs onto what was the difference in the response time according to the different neighborhoods in San Francisco. This was an yearly trend line chart which shows how the number of calls, number of fire incidents are increasing per year. So this can be amounted to the number of increasing properties in San Francisco, but it could also be because of lack of vigilance and such. This is something that would have to be further investigated to understand why every year we see an increase in the number of fire incidents. The final data visualization tab that we have made was for the incident and the response time analysis. So these are the incident counts by the call type. Then for different neighborhood districts in San Francisco, we have a count of the number of calls that were made. So from Tenderloin, we had almost 540,000 calls. Then from Nob Hill, we had 138,000 calls. From Chinatown, we had 91,000 calls, and so on and so forth. Here you are able to see a better visualization of the response time for different areas. Now, this has been mapped for minutes. So the y-axis here represent minutes, 0.5 minutes, 1 minute, and 1.5 minutes. The reason it shows 1.5 minutes is because this has been averaged according to the district and according to the number of fire incidents. So, say we had 50,000 incidents in total in a month or in a year or over the entirety of San Francisco, then we first group it by the district and then we group it according to different years. So when we average it out, the time response actually becomes very impressive. It's almost the highest response time that we saw was 1.77 minutes and the lowest response time that we saw was 1.2 minutes. So this with this data, we can identify that what are areas which need much more fire vigilance because they have the highest amount of average response time by their neighborhood, by the district and such. And so now we come to the final conclusion. Um, this project was not just a project, but was more like a journey for us to delve into the different intricacies of the of data visualization. We further invite you to go through this data set. We invite you to explore and interact with our stories. And here on this page, you will be able to go through our insights and the suggestions that we have made for improvement. I'll read out a few. So the first one was that we decided that we can implement community awareness programs to educate residents about these different safety measures and prevention strategies in high-risk areas as Tenderloin, south of Market, Mission Street, as you saw in the previous graphs. We also thought about establishing a community task force, which would comprise of residents, local businesses, emergency services, to foster a more collaborative approach and addressing fire safety concerns and implementing preventive measures. We'll go through all of these when we present our project at the booth. Thank you so much.